Bismillahirrahmanirrahim. Hi and welcome to LaTeX for everyone and everything. I'm Dr. Noman. I have a PhD in computer science and a postdoc from Max Planck Institute for Software Systems, one of the world's leading research institutes. Well, enough about me. Let's talk about the course. Whenever you look at books, you see that they are professionally typeset. They look really good. The figures seem to flow really well together and the colors have harmony with each other. On the other hand, our documents look something like that. Well, that's plain boring. Well, the reason is books have professional typesetters who understand fonts terminology. They know what serifs are, and what bars are, and what all of the other stuff is. Well, we don't have time to take care of all of that because we have our own specializations to worry about. That is where LaTeX comes in. It's a professional typesetter in your pocket. Typically, LaTeX is used to write scientific papers and technical books. However, that's not all. In fact, I use LaTeX for everything, hence the name of the course. I use it to write applications for research grants. I use it to create my exam papers. For instance, I just tell LaTeX that I need to have a question which has 3 lines for the answer and it's going to have a score of 2. LaTeX takes care of creating these dotted lines for me, perfectly placed, perfectly aligned, and it creates a beautiful score box for me automatically. Not only that, it uses the same piece of information that I gave it just once to create this output table for me where the 2 score is automatically populated. That's how intelligent LaTeX is. Moreover, I use it to create figures. Try doing this in your drawing software of choice. These are 36 perfectly aligned crisscrossing lines. It's extremely difficult to do in any other software, but in LaTeX it's extremely easy. I use it to create perfect UML diagrams, sequence diagrams, class diagrams, activity diagrams. We have a package for everything that you can imagine. And of course, who can forget slides? These slides are created in LaTeX from scratch. Everything that you see on the screen right now has been created in LaTeX. Well, of course, not the window of the PDF viewer, but everything that is in the PDF. Look at the graphs, they look really nice. The font flows together really well. We have very beautiful color combinations. Everything just seems to fit together, perfectly aligned, perfectly harmonious. The references are to die for. If you try to do that manually and then you have to rearrange them, it's a real big pain in the back. But with LaTeX, it comes so naturally that you'll ask your supervisor to have you reorder the stuff. Well, not really, but you get the point. In this course, we're going to be talking about everything that you need to know about LaTeX to get started and to get up to the professional level. We'll talk about the basics, of course, the installation on Mac and Windows, and we'll talk about research papers, we'll talk about templates and switching between templates, we'll talk about references and citations, we'll talk about maths and graphics, we'll cover how to create slides that look beautiful but don't really shout out that I was created in LaTeX. We'll also have some optional content that allows you to create figures like this one. In fact, we're going to have this one as a case study and show you how you can create really complicated figures, scientific figures, really easily, which save you time and create professional looking output. So thanks for your time. Enroll now in the course and I'll see you inside.
Hi and welcome to the course. I've updated this video for the latest version of Windows and all the needed software. If you have any trouble, please do post in the Q&A. The rest of the videos in the course are going to be perfectly applicable with this latest version of LaTeX and Windows. So anyway, we are going to need 2 pieces of software. We'll explain what each bit does later on in the course, but for now, let's just get through the installation first. So the 2 pieces of software that you need are one, LaTeX itself. So this is going to be the piece that is going to take your instructions and generate final documents for you. The other is going to be an editor where you are going to type the instructions. Right? So we need both of these. The actual LaTeX compiler is TekLive. So TekLive is what I recommend even on Windows. Some people will tell you that if you're on Windows, you should be installing MikTeX. But really, I don't recommend it because MikTeX has certain problems that will cause headaches down the line. So TekLive works perfectly fine. You might also be tempted to go with Overleaf, which is an online LaTeX editor. So I have a separate video on how to work with Overleaf That will be later on, but I highly recommend that you do install LaTeX on your local machine. It's going to save you headaches down the line. For instance, if you don't have an internet connection, you're traveling somewhere, or you just want to keep your documents on your local machine. So I highly recommend that you install LaTeX on your machine and keep Overleaf as an additional option. So anyway, in order to install TechLive, the first thing that you need to do is go over and download the TechLive ISO. I'll provide a link to this as well, but you can just search for TechLive ISO and click on the first link. This will bring you to the tug.org page where you can click on download from a nearby citation mirror. Clicking on this link will take you to the download page. And from here, you can simply download techlive.iso, which is approximately a 4 gigabytes file. So it has everything that you're going to need. So you download it once and then you can run everything offline. So this is the first thing that you need to download, techlive.iso. Okay, so this file over here. The other thing is your editor. For people just getting started, I recommend Tech Studio. So you can head over to techstudio.org and click on download now, and that will download the file for you. Do not install Tech Studio after downloading. So there is a specific sequence of steps that you need to do to minimize the hassle down the line. Okay, so we're going to come back to this in just a minute. So you've downloaded the techlive.iso and the Tech Studio installer. So the first thing that you want to install is TechLive, not Tech Studio, but TechLive. So you install TechLive first, and that will make it easier for you. You simply right click on it and click on Mount. This will open up the CD image, which you can use to do the actual installation. So simply click on Install TL Windows, double click it or right click it, and then click on Open. It will take just a little bit of time, and then you will see the installer page over here. So let's bring this over here. All you have to do is simply click on Install. That's it. And it's going to take care of the whole installation for you. It does take a little bit of time because it has to install approximately 4,000 packages, but you can just go and grab a cup of coffee or something, and it will be done in like half an hour or so, depending on your machine and the performance that you can muster. So we'll come back to this after it's done. So once the installation is done, you can click on close and then go ahead and install Tech Studio. So simply right click and open, or just double click on it. The installation is straightforward. You can simply click next and next and next and next, and the defaults work perfectly fine. This won't take too long. It should be done really quickly. And once it is, we can go ahead and close this installer as well. So click on close, and now this is done. To test the installation, we're going to compile a very simple file. So again, you don't have to understand what it is at the moment. We're just going to make sure that everything is working fine. So simply start Tech Studio. Remember, you are going to use Tech Studio as your editor, and TechLive is going to be running in the background. So start Tech Studio, and you will see a screen that looks like this. Simply click on Open and open this first -doc file that you have downloaded from the resources section. So download the file from the resources section, put it anywhere you like, and open it in your Tech Studio. Okay, so we are going to open this. This is a very simple file. You don't have to understand what it does at the moment. We are going to build it so that it turns into a PDF. So we are going to go to Tools and Build and View, or you can simply click on F5 and that will work as well. So for the first time, it might take a little bit of time, but if you scroll up over here, you can see that Hello World has been output over here, which is this guy. So make sure that you get the output and everything is working fine. If you see Hello World over here, it means your installation went fine and everything is peachy. If you have any troubles, please do post in the Q&A and I will try to help you out. In the next videos, we are going to start working with LaTeX and see what you can do over here and what sorts of outputs you can generate. So let's start that now.
Installing LaTeX on Mac is really easy. All you need to do is go get MacTech 2017 or whichever version is available. I'll be posting the link to the course page. You need to go to MacTech download and simply download the package file that is available over here. The package is really easy. It's a simple step-by-step installation. The wizard will guide you. You just need to take the defaults and everything should work out fine. The next thing that you need to do is install Tech Studio. In my opinion, Tech Studio is the best LaTeX editor around. There are other options. Some are specific to Mac, some are general purpose, but Tech Studio works really well no matter which operating system you're on. So I highly recommend you download Tech Studio for this. This is also an OS X DMG. So you simply open it and drag Tech Studio to your applications folders. and you should be good to go. After that, go ahead and start TekZ Studio. So you see the screen when TekZ Studio starts up. You need to download the code zip file from the course page and then go ahead and try to open a first doc file. So this will be called first-doc.tex. You need to open this file and simply go to Tools, Build and View, and you should see Hello World over here. Don't worry about the contents of the page in this file right now. We'll be discussing this later on, but we need to make sure that our installations went fine so that we can go ahead and work with code. If you have any problems with the installation, please feel free to post them on the course page, contact me, and I'd be happy to help. Hi, so you've done the installation and now you want to start creating documents. So first thing you need to do is download the zip file, which includes all the codes. I'm going to explain a little bit what the structure of the code is. So we have a couple of folders over here. We're going to start working with demo 1. And as you can see, we have a demo 1-begin and a demo 1-instructor. So demo 1-begin has all the files that we need to start working with. And demo 1 instructor is the end product that we will make at the end of this section. So that is just for reference. This demo 1-instructor is just for your reference so that you can later on look at the completed code. We're going to copy this demo 1-begin and paste it in a new folder. Now you will notice that I'm using Mac for these demos, but the great thing about LaTeX is it doesn't matter which operating system you're using. As long as you're using pure LaTeX, the code is going to run as it is on any operating system that supports LaTeX. So even though I'm using Mac, you can use the exact same thing on your Windows or Linux machine. So we're going to copy this over here. Now we have a demo 1-begin folder here. We have a small PDF file over here which looks like that, and we have some dummy text file which has some text in it, not really useful at the moment. We'll come back to this, and we have a subfile.tex. So let's forget about these files for now and go to our TekZ Studio editor. Now the first thing that you need to understand is that we have two things over here. One is TekZ Studio, which is our editor. In this we are going to write our source code. So this is sort of like a programming language. You define what you want to do in your source code, and then you have a compiler, which is in our case TekLive, that we have installed previously. This is going to be our compiler, and this is going to convert our source code into an output file, which in most cases is going to be a PDF, right? So what we want to do is define what our document is going to have through our source code, and then tell TekLive to create a PDF for us, right? So let's begin with a simple example. So we are in TekZ Studio. Let's get rid of that, and we're going to define what kind of document we want to create. So we want to create an article. So we say document class, and in the braces, curly braces, we're going to say article. Now LaTeX has commands. Commands are defined or specified using a slash. So we have a slash, and then we have a command name, which is document class, and then we give this command some arguments. For this document class, we have just one argument, which is article. So in the curly braces, we're going to say that the document class for this document is article. Now there are several types of document classes. We'll come to more document classes as the course progresses. Let's start with the article for now. Now what we want to do is we want to say that we have a document, right? So we say /begin, and then we say, now this /begin is a command, and we say that we want to begin a document. Now whenever you begin a document, you also want to end it, right? So between the begin document and end document, we're going to have all the content that is going to go in our document, this document that we are creating. So we have a source file. In it we are defining a document. Let's just put hello world here, and then go ahead and save this file. Now we want to save this file in the same folder where we have this demo 1-begin that we just copied. As you can see, these three files are there. I'm going to save it as first-doc.tex. All LaTeX files must end with a .tex extension. right? So let's save it. And as you can see, this file has now appeared over here, right? So let's go ahead and compile it. We go again to tools and build and view. If you recall, you can also hit F5 directly to build this document and view it over here. So this is what we did last time after we installed the softwares. Now we have this hello world over here. Now what we want to do is we want to specify some other information about this document, right? For instance, what we want to say is what the title of this document is. Since this is my first document, I'm going to come over here before the document and say /title. So this is a command which specifies the title, and this is my first document, right? So this is closed. Now I've defined the title, and I'm saving this file as I go along. I've defined this title, but I haven't placed it in my document, right? So I'll come back to that in a minute. I say /author. Who is the author? Well, since I'm the author, I'll say Norman. You can put your own name in there. And now inside the document, by the way, when you begin and end something, this is called an environment. So this, within this whole thing, between the begin document and end document, we have the document environment, right? So up until now we have a command and we have an environment. So in the document environment, I can say /make title, right? If I hit F5, now I have this document created. As you can see, it looks good already. The title is center-lined, it's in a larger font, my name is there, and make title ensure that the date is automatically inserted, and that's today's date. So we've created our first document. It looks nice. It doesn't have much text in it, but we'll get to that in the next video. All right, so we're now trying to look at how to cite different papers using LaTeX, right? So it's really easy. It says create a main document file, right? So we have this main document file over here already. Collect bibliography entries in a .bib file, right? So for this, you can either go to Google Scholar or you can go to ACM or wherever. I'm going to give you two examples from this. For instance, I came to scholar.google.com and I searched for my paper, Apex Android. So I verified that this really is the paper that I want to cite, but how do I cite it? If you go over here, you'll see that this is a cite button. You click on that. What we want though is to go to this BibTeX, click on this, and you'll get a strictly formatted BibTeX entry, right? So BibTeX is like a sister to LaTeX. It allows us to handle our bibliographies as the name suggests. So what we're going to do is copy this whole thing over here, right? So we're going to right click and copy and go back to our editor and create a new file. We're going to save this and we're going to call this file save, and we're going to call it our bib file .bib. So it should have an extension of .bib, which is for bibliography. We save that, and now as you can see, it has been properly color coded. Let's just take a real quick look at it. So it's an in proceedings type bibliography, so it has in proceedings at the beginning. You don't really have to understand all of this at the moment, but it's good practice to go through the code that you're writing. So this is the key. This is how we are going to identify this paper. I don't really like this format of author, year, and then a keyword, so I'm going to change it to Apex, which is the way I remember this paper. Then I'm going to say dash Norman, which is the author, and then I'm going to put in the year. So it's much easier for me to remember Apex Norman 10 than the other one. The title of this paper is equal to bracket, and within this we have this whole title. There are the authors, where it was published, the pages, all of that. So let's do a quick recap. We searched for the paper on Scholar. We clicked on the cite button and then we clicked on BibTeX. We got the BibTeX, we copied it, we pasted it in another file. So we just have to create this file once. We can put all of the different entries over here. We'll do that in a minute. Now we go back over here, and at the end we first define what kind of bibliography style we want. So bibliography style is going to be plain. This is the format which is supported by many different organizations. Now our bibliography itself is going to come from bib file, right? So this is the name of the file, bib file minus the extension. So bib file.bib turns into bib file. And now we go over here and we want to cite the paper here after the slash so on. And we're going to write slash cite, and as you can see, Apex Roman 10 appears automatically over here. We can use that to populate it. And as with ref, we want a non-breaking space character over here, right? So a tilde so that the cite remains with the dot, right? So if you bid that, you will see that it's going to populate this automatically, right? So everything, the authors get placed at the right place, uh, title, everything gets done automatically for you, right? So and so on. We have a one over here, we have a one over here, everything seems to work out fine. So that's good. Now we go back over there and find another way of citing, right? So you can also go to the ACM digital library, search for a paper, and you get to this page over here. And let's say this is the paper I want to cite. So I click on this and I arrive at the page over here. So over here, you're going to have export formats. If you click on BibTeX, this box is going to come up and you essentially get the same kind of thing, except the key looks really weird, right? But we can change that. So you can take this as well. But I find the Scholar method a lot easier. So let's just go back to the Scholar, and I've searched for deep learning and I have this site. I click on BibTeX and I get this citation over here, right? So I copy that, I bring it to my bib file and paste it over here, right? I go over there, I search for DeepSec, which is another one of our recent papers. I copy that, I paste it over here, right? So essentially the way you do this is whatever paper you read, you can just keep pasting their bib entries into this bib file once. So you take this bib file with you, well, all your life. Like you can just put whatever you want in there. Right, so we go back to our doc, make sure let's save this. We go over here, and because this is already there and the bib file is already there, all we have to do is come over here, say tilde slash cite, and now I want to cite Lacoon over here, and in this, after this I want to cite the third paper, right? So I hit F5, and after a little bit of time, it's going to insert 1, 3, and 2. You'll notice that the ordering is a little bit off. That's because the plain format dictates that, right? So it depends on which format you're trying to use. If this was in IEEE format, this would come out as 1, 2, and 3, but depends on the format. In the next video, we're going to change the formats a little bit and see how easy it is to go ahead and change the format once you have this basic structure down. All right, so see you there. Hi. So as you know, there's no escaping math. So in this section, we're going to take a look at some stuff related to mathematics and how to typeset them easily in LaTeX. So as before, demo3-instructor is our end product, and we're going to start with demo3-begin. So let's make a copy of this over here and open up the math-doc.tex file. So I've put in some text over here. It's basic article. We have included a package which is AMS Math, which is going to let us do quite a lot of stuff. So it has a lot of commands related to mathematics. We have a title, we have an author, make title, the typical stuff, right? So let's build it first and see what's there. So the very first thing we need to do is insert an equation, right? So an equation is going to be some collection of mathematical symbols. There are two types of equations. One is the inline mode equation and the other is display mode. So inline mode, essentially, as the name suggests, is going to be an equation which is going to be within the lines of the text. So for instance, we're going to have an equation over here, and to start we should probably start with e is equal to mc square. So we're going to have two dollar signs, and within these two dollar signs we're going to have an equation which is going to be an inline equation, right? So let's build that and see what it looks like, right? So I'll have to find it. So e is equal to mc. Of course, that's not the correct equation. We need to put a square after the c. So how do you put a square? So a superscript or an exponent is put in LaTeX using the caret symbol. So if you say mc caret 2, that's going to mean e is equal to mc square, right? So anything after the caret is going to go into the superscript. Of course, if you want to put two things in there, for instance, if it was e is equal to mc raised to the power 12, we would have to enclose this in braces. So this brace gets attached with the caret and it's going to be superscript all the way, right? If we did not do that, if we just said 1 2, so this 1 would get attached with the caret and 2 would be in the normal text, right? So of course we need to make it easy to MC square, so let's fix that. So this is inline mode, right? If you want to take the same equation and put it in display mode essentially means that it's going to take up its own space and it's going to have its own block. So for that we have an environment which is called the equation environment, right? So we have begin equation and end equation and we give it a label, and here we're going to put e is equal to mc square, the same equation. As you can see, now it has a little different structure. It's centerlined within the text and it has been given a number which is the number 1, and this numbering is going to be automatically handled by your document class. So now we have an inline equation and a display mode equation. And now what if you don't want to have this numbering in an equation? Maybe you have some cases in which you don't want an equation number, right? So for that you can go ahead and say begin equation star, right? So this is a star variant of the equation, and this comes from the AMS math package that we have already used above in the preamble, right? So we can put e is equal to mc square over here, and it's going to output the same thing but without the numbering. So this is a star variant. These are called star variants of environments, right? So star variant of the equation environment. Alternatively, you can use a shortcut which is slash square bracket and slash end square bracket, and within that if you put e is equal to mc square or whichever equation, this is going to have the exact same effect as putting in an equation star. So this is very commonly used, so we have a shortcut for that. And by the way, you can read the text, it has some information in there, but we don't really want to read every bit in detail in this video. So we can go ahead and refer to this equation since it has a label which has the prefix of eq. Again, this is by convention, we can give it any name, but we have decided to call it eq colon mc square, and we can refer to it using the same ref command that we did earlier on the videos. So equation tilde slash ref eq mc square leads to this, for example equation 1. So this one comes from eq colon emc, right? So now we have simple equations and we have ways to refer to them, and we have a way to suppress numbering for these equations. In the next video we're going to take a look at how to do slightly different things with the equations, different symbols, and how to incorporate them. Hi, welcome back. So we've come a long way. Now what we want to do is start another aspect of our course, and this is going to be related to creating presentations. So as before, let's go ahead and copy over our startup code. This is going to be demo5-begin, and as always demo5-instructor is your end goal. So let's copy it over here and open this up. So as you can see, we have set this to document class article. We have a title, a date, an author, begin document, make title, and end document. This is our basic skeleton. So for a presentation, the first thing that we need to do is change the document class to Beamer. So Beamer is a package which lets us create really good looking presentations in LaTeX. So most of the code that we write within this begin document and end document is going to be LaTeX code, with only a few differences thrown in because of the Beamer. And the first thing that you need to know is that all Beamer documents are composed of frames. So if you come from PowerPoint or Keynote, the frame is the equivalent of a slide. So we say begin frame and end frame. And so within this begin frame and end frame, we are going to have a slide. So let's create our Hello World presentation. Let's build this, and you will see that we get a proper make title created slide. This is the title slide. Now this is the same make title that we used in the article class. It had a different effect there, it has a different effect here. right? And we have this single frame over here which says hello world. So we have two slides now, one for the title and one for our hello world. Now let's proceed with another frame. So let's create frame and slash end frame, and within this we want to write some text. Now you'll notice that the text is being centrally aligned vertically, right? So that is the default in LaTeX, and it has a lot of pros, right? It's generally recommended that you keep it that way, but sometimes you want to top align the slide content. So in order to do that, we're going to pass an option of T to the begin frame environment. Right? What that does is it takes this text and places it to the top of this frame. Now, because we don't have a frame title over here, this looks weird. So let's go ahead and insert a frame title in the first frame. This is going to be my first frame. Right? So when we build that, we get our title over here. Now there are two ways to insert the frame title. One is this one that you just saw, and the other is to pass it as an option. So introduction. So this one gets an introduction title over here, and some text is over here. You can do a paragraph break and insert some more text, and this seems to work fine. Now I understand that this looks weird, a little weird. Even more text. So that's one of the limitations, so to say, of using Beamer, that your slides are going to look bland at first, but we're going to fix that. I promised you that your presentations are not going to look like they were made in LaTeX, like every other single presentation that is ever made in LaTeX. So we're going to come to that in one of the later videos. Just trust me on that. For now, just stick with understanding the syntax of Beamer, right? So the first thing that we need to do now after our basic structure is to insert some sections, right? So if you remember, we had sections in articles. Here we have another section. So let's say this is a background section. This has this one frame over here, and it can also have another frame, begin frame, another background section, right? And we have a slash section introduction over here. So we have a section that is for introduction. Let's put this over here so that it's much more visible. If you recall, this is a comment, so it will not affect our output. So let's build this, and you will notice that nothing has changed, right? But we're going to change that in a minute. So after make title, we want to insert frame. This is going to be a special frame, and it's going to have the title of outline. And the reason for that is we are going to insert a table of contents here. Now if you hit F1, you get an outline page which has these sections listed over here. If you click on that, you go to the corresponding section. So if you click on background, you go to the background section. Maybe we should go ahead and change this introduction to background frame so that it's much more visible. So if you come over here, you click on background, you go to background frame, because that is where the section is starting from. So now we have a basic structure of a presentation. We have a way of creating outlines. We have a way of inserting frames. We can always go ahead and insert, for instance, equations in this. Is equal to mc square, our favorite equation. This is going to go over there, and it's going to work just as it is supposed to. So that's the basic. In the next slide, in the next video, we're going to go ahead and take a look at a few other constructs that are available in Beamer, and then change the outlook of our presentation. So stay tuned. All right, so welcome to the last section of this course. As I promised, I'm going to have a case study of drawing figures using LaTeX. Let's go ahead over here to our demo 6-begin. As always, demo 6-instructor is the final product that we're trying to create. And as I told you, we're going to try and create a figure that looks something like this, right? Except we have three circles here. We're going to create 6 of them. Let's go ahead and open our file. As you will notice, we don't have an author, a title, and a make title over here this time. That's because we're trying to create a figure, and a figure in itself does not have an author and a title. It gets embedded into another document that has these pieces of information. So let's go ahead and change first this article class to standalone. In fact, let's first start with article and see what the difference is. So let's go ahead and keep this document structure and begin our figure drawing procedure. So for that, we're going to need the package TikZ. So TikZ is a package that lets us draw figures, and we're going to have a begin TikZ picture and an end TikZ picture. So within this environment, we're going to have our TikZ picture. So let's go ahead and create a simple node. So every text that you want to place in a TikZ document is going to be through a node. So let's go ahead and place a node that is going to have a content called h1, right? So very simply, we're going to have an h1 over here, right? So nothing complicated, just an h1. Let's build that and see what happens. Now, as you will notice, the article class uses the standard A4 or letter size paper, and we don't want that. We want a figure that is only as large as our content. It should not have page numbers and everything around it. So for that, we have a very special document class called standalone, and with this standalone, we can have the image or the page of the image only as large as it is needed. Right, so we have an h1 over here, nothing else. So our page, so to say, is going to be only this wide. Right, so we have a node h1 over here. What we want to do is we want to name this node something. So we want to call it h1. So this h1 over here is the name of the node, and this h1 over here is what is appearing on the page over here. What we want to do is we want to make sure that this is an h superscript 1. So we call it, put it in the math mode and use the caret. So you can use math, right? Whichever math. You can use fractions over here, you can use square roots, whatever you want. We just want to keep it simple. So we have one node over here, h1, and we want to place it at location, let's say 2, 3. So this is the x coordinate, and this is the y coordinate. So we're going to work with coordinates over here. So let's build that. It doesn't make a difference because still we're going to clip the page around it, but the difference will be seen when we put an h2 over here. So this is a node h2, and it has been placed at 4, 3. So your x location has now changed, and h2 gets placed over here. You can go ahead and create another one. So h3 is going to be placed at 2, 4, 6, and this is going to be h3. So we have 3 h1, h2, and h3. So you'll immediately notice that the output is looking somewhat like what we were trying to make. We also need to have some x's. So we're going to create a node which is going to be named x1. It's going to be at 2. So right below h1. So instead of 3, we're going to have 0 for the y coordinate. And here we're going to say $x underscore $1 and 1. Right? So I realize this looks like too much work, but rest assured we're going to fix this in a while. So we have x2 over here, and this is going to be at 4, 0, and then we're going to have x3, and this is going to be at 6, 0. There you go. So we have h1, h2, h3, x1, x2, and x3. Now, what we want to do is create a path between h1 and x1, and except we're going to call it an edge, right? So an edge that should be drawn, right? So the way to read this is create a path from h1 to x1, and the path itself is going to be an edge that will be drawn. Right? So there are other options here, but we're going to stick with the simplest ones. So there is a path from h1 to x1. Now you'll notice that because we're defining that a path should go from h1 to x1, and we're not limiting ourselves to specific locations, if I move x1 around, let's say if I move this x1 to -2, the path is going to follow it along. So this works out really well. Once you have the diagram ready, everything else just seems to work really well. So we also want a path from h1 to x2. We also want to x3, one from h1 to x3, and so on. Now, we also want, this is getting really annoying, right? So we're going to fix that in a little while. So h2 to h3, h2 to x3, and we also need to go from h3 over here, right? So that's fixed, but we have a couple of problems. We needed circles around all of these, and this is really difficult. If I had 6 of these boxes here, h1 up to h6 and x1 up to h6, I would have to write this thing 36 times. I don't want to do that. It's not as bad as a word processor or Visio, for instance, but still I don't want to do all of that grunt work, right? So we're going to fix that in a while. So we've come a long way, and I've covered all the content that I wanted to cover for this basic course. But as you can see, LaTeX is a huge world. There are several people putting hours into hours of their daily lives free of cost into this system, and it really is a beautiful system to work with. I'm very passionate about this system, and it would really mean something to me if I can get more and more people to come over to LaTeX to create better professional looking documents. In this last parting video, I want to leave you with some helpful hints that might let you move ahead and explore more of LaTeX and get better output of your documents using these tips that I've learned over the years that I've been working with LaTeX. So the first thing I want to show you is the LaTeX font catalog. If you want to, obviously you shouldn't be using too many fonts, but you should be using the right font. So if you're searching for inspiration, you can go to the LaTeX font catalog, and it will show you all the fonts that you can really use in LaTeX without having to install them or anything. So you can go over here, and for instance, you can click on serif fonts, and you will see all of these fonts that can be used very easily in presentations. In fact, I've got the Fira Sans font that I showed you earlier in one of the videos from over here. So what you can do is you can go ahead and search for the font, whichever one you like. You click on it and you get to this page, and it shows you a text sample, what this font looks like. It looks much prettier than it's appearing over here. It looks much better in print and on screen. So it also shows you how to use it. Simply go ahead and copy all of this and paste it in your document, and it should work fine. And it gives you some variations over here as well. Another font that I really like is Roboto Thin. This is very good for on-screen and presentation modes. It's good for headlines, headings. You might want to use it using the use package such and such and another use package. Right, so it's very useful if you want to have different fonts in your document. So just head over to LaTeX font catalog. Just make sure you don't overdo it and include too many fonts in a single document. Another thing that I want to share with you is the document that got me started with LaTeX. It's called the Not So Short Introduction to LaTeX. So if you search on that, you will find this as the first PDF, and if you open it, you're going to see that it's 171 pages, which for LaTeX is quite short. But it's still called a not so short introduction to LaTeX. So you can go over here, and it has a lot of examples. It talks about bibliographies, indexing, fancy headers, lots of examples, side code and output side by side. For instance, you can go over to fancy header and see that it's explaining what this thing, what your code should be, and what the output is going to be. Right. So this is a very good document to go through if you have time and you want to make your LaTeX skills even more powerful. If you get stuck with LaTeX, of course, I'm here to help. You can ask me, but I do have my own limitations. I may be a pseudo expert in LaTeX, but there might be things that I don't understand. Uh, for that, you can go over here and take a look at one of the best question and answer websites on the internet, hands down. And no, I'm not talking about Stack Overflow. I'm talking about a sister of Stack Overflow, which is called the tech.stack exchange. Now, you might have heard of the horror stories that newbies have with posting questions on Stack Overflow. It's not the case on tech.stack exchange. This is a very, very friendly community. If you ask questions over here, you're going to get a really good response. You're going to get encouragement for trying to learn LaTeX. You're going to get useful answers. You're going to learn a lot if you try to post it over here. Don't worry about getting ridiculed. That's not going to happen on this website. Just make sure that you approach the problem professionally, and it's a really good site to learn. In fact, I learned a lot of what I know from over here. Most of these 2000 reputation points come from asking questions instead of answering them, right? So please try it out. I'll just leave you with one example of the question answers. I posted this asking that I want to create a cloud that looks like this instead of this, and I had this guy go ahead and manually create these two clouds, right? And this is a guy with 68,000 reputation points, so he's good, but he's very friendly as well. That's rare to see. And there is another answer over here as well. So don't be shy to ask questions over here. Obviously, you can post on the course page, and I'd be happy to help out. But these are professionals who are creating LaTeX packages, so this is a very good resource to have under your belt. So I hope you enjoyed this course, and I hope you can create documents in LaTeX, share them with me so that I can know that you learned something from this course and that I was able to help out someone with creating LaTeX. Goodbye and have a nice journey.